In this section, we're going to discuss marginal revenue. Recall our profit equation. Profit equals revenue minus cost. So we're going to see marginal revenue when we start to calculate profit maximization. So what exactly is marginal revenue? Well, marginal revenue is the incremental increase in total revenue from producing more units. So we can write this as change in revenue over change in Q. Or if we consider small changes in Q, we can write this as a derivative of revenue with respect to Q. So d revenue dQ. So let's go back to our example of price-taking firms. And recall that price-taking firms cannot set the price, they cannot change the price, they take the price as given. So in our laptop example, price was set at $300. So the revenue you get from that will just be P times Q, so 300 times Q. So the marginal revenue is going to be equal to price. That's because every additional unit you sell, you'll still only get the $300. So once again, in the price-taking setting, marginal revenue will be equal to price. So we can also just calculate this using calculus. So it's a little bit overdoing it for this simple case, but I'll show you nonetheless. So marginal revenue, recall, is the derivative of revenue with respect to Q. So taking the derivative of our revenue equation, which is 300Q, just gives us a value of 300. But what about the case when firm can set the price? So let's take the example where we're making very unique laptops and we're selling them at our own stores. So in this case, marginal revenue will be less than the price, or equivalently the firm's demand. So let's take a look at an example with some discrete values. So on the left-hand side we have quantity. Next to it we have price. So these two columns make up our demand equation. So as quantity increases, we see price decreasing. Then we can calculate the total revenue because we know that revenue equals price times quantity. And then furthermore, we can calculate the marginal revenue. So as we increase quantity by 1 unit, we're going to look at the change in total revenue. So when we increase quantity from 0 to 1, total revenue increases from 0 to 8. So that means our marginal revenue at quantity 1 will be 8, and we can continue that calculation all the way down. And you'll see that initially marginal revenue starts at 8 and it decreases down to -8. So it is possible to have negative marginal revenue. So let's graph this out to see what it looks like. So let's consider selling 1 extra unit. So we're going to start at Q0 and we're going to increase units sold to Q0 plus 1. In order to sell that extra unit, we need to decrease price, or else consumers won't be willing to buy that extra unit. So that lighter rectangle on the bottom represents the gain in revenue from selling that extra unit, but we're selling that extra unit at the price P1. So now that we're selling everything at P1, there's also an associated loss. So previously we were selling at P0, a higher price, and now we're selling at P1. So the darker rectangle represents the loss associated with selling 1 extra unit. So we can represent marginal revenue as the net effect of this gain and this loss. So this is equivalent to price plus Q0 times the change in P. So these just represent the areas of those rectangles. And since that second term, Q0 times delta P, is negative, marginal revenue is less than P1. So we can also go a little bit deeper with our calculus here. This isn't necessary, but I'll show you anyway. So using our product rule, we can take the derivative of price as a function of Q multiplied by Q. So remember, this is product rule here because we have a function, 2 functions actually multiplied by each other. So our marginal revenue again is d revenue dQ. So taking the derivative of this will give us PQ plus Q dP dQ. So this is very similar to what we just showed for the marginal revenue equation based on just the graphical analysis of the gain and the loss. So remember, that was P1 plus Q0 times the change in P. So let's actually do or work out an example here. Let's start with our demand equation. So we have 1,000 minus 5Q Q. So first thing we can do is calculate our total revenue, or revenue, same thing. And this, of course, is just P of Q times by Q. So subbing in what we know, and then we want to multiply through. So we're going to get 1,000 Q minus 5Q squared. Now let's calculate what marginal revenue is. Well, remember that marginal revenue is the derivative of revenue with respect to Q. So that's just going to give us 1,000 minus 10Q. Let's look at that. So here on our graph, our first line shown is our demand curve, so the 1,000 minus 5Q. And our marginal revenue is 1,000 minus 10Q. So notice that when you have a linear demand, our marginal revenue has the same y-intercept, in this case it's 1,000, but the slope is doubled. So we went from -5 to -10. So that will always be the case when you have a linear demand curve. So here's the marginal revenue graphed on the same